All right, picture this. A massive paper order drops in. Let's say 50 metric tons of 70 GSM craft paper. Now, if you're a paper mill owner here in India, you know the drill. Processing something of that scale usually means plunging into a maze of spreadsheets, endless phone calls, and manual data entry across entirely isolated departments. But what if you didn't have to? What if you could track that single massive order through your entire plant, literally from the front office straight to the loading dock, without typing in a single manual data entry? Well, in this explainer, we're diving into the Papyrus BPApp. We'll follow the exact end-to-end journey of one paper order to see exactly what a truly synchronized operation looks like.
Okay, let's dive into this with our factory map. We'll trace this 50 metric ton order through 6 key areas. First, sales and planning. Second, procurement and stock preparation. Third, machine operations and AI. Fourth, quality and broke management. Fifth, dispatch. And finally, finance.
So, starting things off with Section 1, Sales and Production Planning. The journey begins. This right here is the very moment the customer's order sparks that whole chain reaction. To give you a real bird's-eye view, here is the predicted service level agreement timeline for our order. On day 1, the customer actually places the order. Boom! By day 2, production scheduling and material planning are completely locked in. Then, day 3 is the physical machine run. Day 4, that's dispatch. And by day X, the payment terms clock starts ticking. The beauty of Papyrus is how it visualizes this whole chronological journey instantly, the very second the order is validated. Now, how is that timeline actually built? Well, the moment our customer submits that order for 50 metric tons of 70 GSM craft paper, the sales module instantly kicks off an automated credit check and an available to promise inventory check. Once it's validated, it automatically triggers the master production schedule, or MPS. Then the system instantly runs a capacity requirements planning check against paper machine 1 and 2 just to find that perfect optimal slot. At the exact same time, the material requirements planning, the MRP, module explodes the bill of materials to see, hey, do we have enough pulp stock in inventory? If we don't, it automatically flags procurement to raise a purchase order to the pulp supplier. It's like a perfectly choreographed dance where every single module hands off to the next with absolute precision.
And I really want to emphasize this specific number. 0. Absolutely 0. That is the exact number of manual data entries, dreaded Excel spreadsheet updates, or, those frantic late-night clipboard checks you need to get from the customer's initial click to a fully locked factory floor schedule. 0 silos, 0 re-entry errors. The system literally just talks to itself.
Moving right along to Section 2, Procurement and Stock Preparation, mixing the perfect batch. So we're stepping out of digital planning and diving right into the physical chemistry of papermaking.
And this brilliantly illustrates how that MRP explosion comes to life. To make our 70 GSM craft paper, the system pulls up this highly specific furnish recipe. It calls for a pulp blend of 70% hardwood, 20% softwood, and 10% recovered broke. But hey, it doesn't just stop at the pulp. The software also executes the exact chemical dosing. It automatically calculates the precise amounts of rosin for sizing, aluminum, and starch to ensure we hit our quality targets perfectly. The real magic happening here is consistency. You see, the stock preparation module is continuously communicating with sensors to automatically control refiner freeness and headbox consistency. It holds that slurry to an incredibly strict plus or minus 0.2% deviation. That's practically unheard of with manual control. It completely eliminates human guesswork before the pulp even has a chance to hit the wire of the paper machine. Which brings us to Section 3, Paper Machine Execution, and the Invisible AI Guardian. We are officially stepping on to the heavy industrial shop floor, where our 50 metric ton order has been assigned as an active work order to a specific machine. To really appreciate how Papyrus manages this, let's compare the two approaches. The old way of running a machine, well, it involves those painful manual logbooks, hourly spot checks, and then waiting all the way until the end of the shift just to calculate your overall equipment effectiveness, or OEE. The Papyrus way, though, uses direct OPC UA DCS integration. What that means is the system connects directly to the machine's distributed control system. It's pulling data on speed, temperature, and output, literally second by second. That gives you real-time tracking of your true operational efficiency.
But let's raise the stakes for a second here. What happens if, say, halfway through our massive 50-ton run, Paper Machine 2 starts drifting out of spec? Maybe a dryer cylinder temperature drops unexpectedly, or maybe there's a weird vibration anomaly that suddenly threatens our entire production run. Then what?
Well, this is exactly where the AI analytics overlay steps in like an invisible guardian. It's continuously monitoring all that machine data. The second it detects an anomaly, it instantly triggers a yellow or red zone warning. This alert pops up directly on the operator's HMI screen, giving them a true predictive maintenance heads-up. By catching that drift early, the operator can just make a quick micro-adjustment, entirely preventing a catastrophic web break and ultimately saving our 50 metric ton run. All right, let's move into Section 4, Quality Control and Broke Management, Perfecting the Reel. The paper is officially rolling off the machine, and now it has to be rigorously tested against the customer's exact standards.
Quality control in this system is just systematic and absolutely relentless. Every 2 hours, there's in-process sampling happening. The online quality control system, along with any manual lab results, gets instantly recorded straight into the database. They're testing for strict adherence to a GSM target, with a tiny ±2 deviation allowance, along with a moisture content of 6 to 8%, plus brightness and tensile strength. The final reel only gets that golden quality clearance if it perfectly hits every single one of these metrics.
But what if a reel fails inspection? You know what happens. Well, in the Papyrus system, off-spec paper isn't just a lost cause. It's immediately logged as wet or dry broke. Then the system seamlessly hands this data right back to the stock preparation module, systematically scheduling it to be repulped and recycled as furnish in future batches. In fact, it usually allows up to 30% broke content safely, so waste is essentially managed as a valuable resource. Now for Section 5, Dispatching the Final Reel, Out the Loading Dock. Our paper has passed all its quality checks, and now we tackle the logistics of actually getting these massive finished reels out of the warehouse and onto the trucks.
The finished goods execution here is fully automated. As soon as the reel rolls off, the weighbridge data flows directly into the ERP. No manual typing whatsoever. The system instantly auto-generates a unique label formatted by month, day, year, machine code, and a sequence number. Once it's labeled, it gets stacked in the warehouse with perfect lot and batch tracking, completely ready for fulfillment.
Next up, the dispatch module takes the wheel. It matches our 50 metric ton order directly to the inventory, creates a delivery order, and assigns a transport vehicle. And since all the weight and order data is already sitting in the system, it automatically generates the mandatory e-way bill and prints out the delivery challan instantly. Just like that, the physical product is handed off to the transporter, complete with GPS tracking so the customer knows exactly where it is.
Finally, we reach Section 6, Finance and the Analytics Loop, Closing the Books. We are bringing the narrative all the way back to the front office to see the financial culmination of our successfully delivered order. So the crucial point is how cleanly this whole thing closes out. The very moment the proof of delivery is captured, it triggers the creation of an e-invoice that's registered directly on the government's invoice registration portal. The system instantly computes the correct GST based on whether the customer is intrastate or interstate. And then finally, it creates an accounts receivable entry and posts the exact cost of production, literally from the pulp all the way to the power used, directly to the general ledger. The entire loop is closed automatically.
And hey, while the payment terms clock starts ticking on that invoice, the AI analytics overlay has been quietly in the background updating the plant's true efficiency metrics. It's continuously calculating your overall equipment effectiveness, which is a measure of availability multiplied by performance multiplied by quality. This gives mill owners a live, real-time pulse on their factory's actual profitability.
When you step back and link every single one of these modules together into one fully connected picture, from that very first sales order all the way to the final ledger entry, the systemic gains are absolutely massive. The sources show a 70% reduction in planning time, a 15 to 20% drop in unplanned machine downtime, and the ability to consistently hit an OEE target of greater than 85%.
We've just watched 50 metric tons of paper move through an entire manufacturing ecosystem with absolutely zero silos and zero manual data re-entry. The whole plant communicated flawlessly. So, the big question to ask yourself is this: is your paper mill ready to finally step away from disjointed spreadsheets and start operating as one synchronized organism? It's a truly fascinating shift in how heavy industry operates, and hopefully this journey has sparked your curiosity to learn a bit more.